Now, let's look at this example which uses our STP concept. So we're going to say a sample of Freon 12 occupies 20.7 liters at 25 degrees Celsius and 947 torrs. Now they're saying, what is the volume under standard conditions? So remember, what are they asking me? They're asking me to find the volume. But here they already gave me a volume. So this must be my volume 1, and this must be my volume 2. They also give me a temperature, and they give me a pressure. And here they're saying under standard conditions. Standard conditions means we have a standard pressure and a standard temperature. So our P2 would be 1 atmosphere, and our standard temperature would be 273.15 Kelvin. Since we're dealing with a gas, we write PV equals nRT. And again, guys, we're dealing with two sets of data. Remember, what have we done when we have two sets of something, two volumes or two pressures? We'd have to check to see who they're talking about. They're talking about pressure, they're talking about volume, and they're talking about temperature. They're not talking about moles because moles are being held constant, so we ignore. R is our constant as well, so we ignore that too. Everything is not on the same side of the equation sign, so divide everything by T to bring it over to the left. So PV over T. Since we're dealing with two sets of data, it's P1 V1 over T1 equals P2 V2 over T2. This creates a whole new type of gas law, which we call the combined gas law. We haven't seen that until now. So this is our combined gas law. P1 over V1 equals P1 V1 over T1 equals P2 V2 over T2. This is our combined gas law. Now, we're going to plug in the units that we know into this combined gas law. But first, you have to change the temperature into Kelvin, and you have to change those 947 torrs into atmospheres. So T1 is 25 degrees Celsius, so all we have to do is add 273.15, which gives us 298.15 Kelvin. Pressure 1 is 947 torrs. We just have to change this to atmospheres, so for every 1 atmosphere, it's 760 torrs. Okay. When we do that, we get our answer as 1.24605 atmospheres. All we have to do now is plug it in and solve for our missing variable. So our P1 is 1.24605 atmospheres. Our volume 1 I told you was 20.7 liters. And our temperature 1 was 298.15 Kelvin. Equals. Now, the pressure 2 is 1 atmosphere. That's really not going to change anything. So we plug it in anyways, 1 atmospheres. V2 is what we're looking for, over temperature 2, which is 273.15 Kelvin. Okay. Now what we're going to do here is we're just going to solve for everything on the left. So do the P1 times the V1 divided by the T1. When we do all of that, the left side gives me 0.086511 liters times atmospheres over K. This still equals my 1 atmosphere times V2 divided by 273.15 Kelvin. Multiply both sides now by the 273.15 Kelvin. Kelvins cancel out. So then that's going to give me 23.6305 liters times atmospheres still equals 1 atmosphere times V2. Divide both sides by the 1 atmosphere, which doesn't do anything. All it does is it helps get rid of these atmospheres in the units. So then V2 equals, we're going to just do 3 sig figs here. So it's 23.6 liters. So that would be the answer for our volume 2. So again, guys, remember, even though we started out with the ideal gas law, because we have 2 sets of data again, we have to manipulate the ideal gas law. Doing that helped us isolate our answer here for V2. Now that you've seen this and now that you understand what STP is, I want you guys to attempt the next question.